Okay, now it is visible. Whatever I shared the diagram.
Yes, sir.
Static equilibrium condition. Now, static equilibrium condition is a very simple thing. For basics of engineering mechanics, you can get an idea. For deriving this static equilibrium condition means just we are trying to resolve the forces. We are trying to resolve the forces of any particle in the space along x, y, z directions, simply in coordinate systems. Okay, in Cartesian coordinate system, just we are trying to equilibrium conditions develop, okay, in terms of its coordinates. So here, for understanding purpose, we are here, what we did is just we consider the one cube. Cube means a cube element, a small element, cube element. Okay, it is placed in the space. Its dimensions change in dimensions in x direction dx, y direction dy, z direction dz. These are the three coordinates, x, y, z directions. Its changes are dx, dy, dz. Okay, this is the cube. Now this element has dx and dy, dz. Now on each face, suppose this one is one face, yeah, this one is one face, this one is one face, this one is like that. How many faces are there? 6 faces are there for a cube. You might be know that. So at each face, what we know that from the previous classes, one is normal stress, another are shear stresses. We know that one is normal stress, another is shear stresses. Or otherwise we can know that. So suppose this one, this plane, suppose we are considering this plane. I am projecting this plane to here. One is sigma xx. Okay, this is normal stress. Another one is tau x y, tau x z. Okay, these two are the shear stresses on each plane. Then we can say that on each plane it has 3 stresses. One is normal stress, another 2 are the shear stresses acting on the components of a body forces per unit volume here, per unit volume, because it is a cube, volumetric dimensions cubic, so that's what each body force per unit volume along x, y and z directions. Okay, now at the same time it may be subjected to forces fx, fy, fz respect to respect to coordinate system, like x direction we may consider the body force fx, y direction fy, z direction fz. Like that we can say that there are fx, fy, fz. These are the body forces. Now what we have to do is we have to equilibrium. We have to develop the equilibrium condition for this cube. Well, now just I am trying to write as planes this cube, then we can convert it into planes, 6 planes. Okay, whatever the cube is there, it has 6 faces. Then each face we are trying to write the stresses or forces which are acting on that plane. We are trying to. Now for understanding purpose, we are discussing here only x direction forces or stresses, what are the acting on each plane we are considering here. Once again I am repeating, for understanding purpose there are the x, y, z directions. Once we know the one, understand the concept of one direction means x direction, remaining 2 directions are same, similar to that. That's what we are trying to understand the concept of this equilibrium condition in x direction. Now once again I am writing this diagram. This is the 6 faces. Now face wise face, we are trying to identify as color. Now this is the face, this one, yeah. Now this face, this one, okay. Or otherwise we can give it as names: A, B, C, D, E, F, G, H. For understanding purpose only, A, B, C, D, F, G, H. Then we can identify that. Suppose I am concentrating this face is A, B, C, E, F. That face, B, C, E, F. What are type of stress acting along x-axis? What is that stress is acting along x-axis? Sigma xx. You might be know that. Okay. Into its area gives the force. First I am trying to write the stresses on. Then we forces. Then we can multiply with its area. Then we can give it. So we know that this is dx, dy. Now I want to write the each face or each plane, they are subjected to different types of forces and stresses. Then on each plane there are some stresses are subjected to x-axis and y-axis. Now we are considering only x-axis forces, only x-axis. Once after finishing this force, BC, EF phase, that is the sigma x-axis. Similarly, I am considering that ADHG, this plane, ADH. Okay, this is subjected to sigma. What is that? X, negative direction. Now another one. Suppose anyone display top line DCD FG, this plane. Now this one is what type of stress is developing here? Next direction. X direction, this direction. This tau yx. Tau yx. Similarly this one in bottom also tau yx. This one ABHE tau yx. Similar another plane, this one means ABCD, the plane. ABCD plane, which stress is acting? Tau zx. Tau zx, and this one is tau zx. Here is, this one is this direction. Okay, in the 6 planes there are 6 stresses or 6 forces acting on its planes. Now after identifying these stresses, then we need to develop one equation, that is resolving the forces along x direction. You might be know that this equation, where the forces are acting, that is equal to 0. Okay, this equation. Now once we know this equation, then we are trying to resolve, or under equilibrium condition, then we are trying to resolve all the forces, that means stresses. This stress multiply with area gives the force. Then I am writing this equation. Sigma Fx equation means what are the forces are acting along x direction are equal to 0 under equilibrium condition. We might know this one. Now I am writing sigma xx dz dy. Okay, stress and its area minus sigma xx dz dy. Here then we just wait. Suppose here we consider the cube. Here we consider the cube. Because of its change of its length dx, the stress is also acting as sigma xx plus d sigma xx. Like that, each plane is same. Why? Because of its change of its dimensions, automatically the stress is also changes. Here suppose this, I am discussing only this one plane. What is that? DAHG, this plane. Suppose starting point here, because of that's what here is acting sigma xx. Now means after acting this side, because of its change of dimensions, automatically stress is also changes. So that is, we can write it as d sigma xx by d sigma xx. That's change of stress. Here we can write it as d sigma xx. Otherwise, once again I am writing dz dy minus of xx plus d sigma xx into dj. Okay, that is one plane is covered. So similarly, remaining other two planes, that is tau zx dx dy minus tau zx plus d tau zx multiply with dx dy. Similarly, another plane tau dx multiply with dx dz minus tau yx plus d tau yx multiply with plus f of x means volumetric total force multiply with its volume dx dy dz, that is equal to 0. Okay, under static equilibrium, just what we are did is just resolving the forces along x direction. What are the forces are acting along the x direction? Just we are trying to resolve. So then this one is because of the changing dimension, this one is cancelled. Finally we can write it as dx d sigma x divided by x multiplied with x into dz dy. Similarly, plus just we are multiplying and dividing with dx, and we can cancel, means remaining equation will get. So similarly, rho tau zx divided by z dz, this one is dx dy plus rho tau yx divided by rho y dy dx dz plus f of x into dx dy dz is equal to 0. Just we are trying to simplify this equation. Now finally dx dy dz, it is common in all the terms. So then if you keep it as outside, then make it this side it will happen. Then remaining equation is xx by x plus tau yx divided by rho y plus x plus f of x is equal to 0. This is static equilibrium condition in x coordinate. Similarly, we can get it for the other two coordinates like y and z also. Then no need to go for once again all these things. Just simply we can write it as, suppose similarly then we can say that sigma f of y is equal to 0 in x y direction. Then what if we can write it as dou tau y x divided by dou x plus dou sigma y divided by dou y plus dou tau yz by dou z plus f of y is equal to 0. This is the equation 2. Means the forces resolving in y direction is 0. Similarly, f of z direction is also 0. Then we can get it as dou tau zx by dou x plus tau zy by dou y plus dou sigma zz divided by dou z plus f of z is equal to 0. This is the equation. Now these three equations are called as static equilibrium conditions. Okay, they are very simple. If you know if you understand the procedure for this one direction, like along x direction, then remaining things are very simple. Okay.